Salesforce's order of execution is a 19-step sequence that runs every time a record is saved. Insert, update, upsert, merge, delete, undelete, all of it. Most developers learn triggers without learning this sequence, and that's where the hard-to-debug production bugs come from. Not wrong logic, wrong assumptions about timing. By the end of this tutorial, you'll have a clear mental map of every step, know exactly where to put your code, and understand why certain patterns like the static set pattern exist. Here's the core insight before we go step by step. Trigger bugs usually aren't logic bugs. The code does what you wrote it to do, but it runs at the wrong moment relative to other parts of the system. A rollup that hasn't recalculated yet, a workflow rule that fires your trigger again, a recursive update that loops until Salesforce throws an exception. Every one of those problems is a sequencing problem. Once you know the sequence, these issues become obvious before you hit production. The biggest misconception is that a trigger runs exactly once per save operation. That's often true, but not always. If any active workflow rule on the object fires a field update, Salesforce applies those field updates to the record, and then fires your before triggers and after triggers a second time. This isn't a bug, it's documented behavior. But developers who don't know about it write triggers that aren't designed to run twice, and then wonder why records are getting updated twice or why callouts are being sent double. Steps 1 through 3 happen before any Apex runs at all. Step 1 loads the original record from the database. This becomes trigger.old. Step 2 merges the incoming field values onto the record. This becomes trigger.new. Step 3 runs system validations, required fields, field format checks, data type constraints. If any of those fail, Salesforce throws an error immediately and your trigger never executes. This is important. By the time your before trigger starts, Salesforce has already confirmed the data is structurally valid. Step 4 is where before triggers run, and it's the most powerful place to modify field values. Think of it like editing a form before you submit it. The record hasn't been written to the database yet, so you can assign values directly to trigger.new field name. No DML statement needed, no DML limits consumed. This is free modification. If you want to derive a field value, format a string, set a default, or calculate something based on other incoming fields, do it in a before trigger. That's the right tool. After before triggers run, Salesforce validates again at step 5. This second validation pass includes everything: custom validation rules you've written in setup, required field enforcement, unique field constraints, duplicate rules, and foreign key integrity. Why does this happen after before triggers? Because your before trigger may have changed field values. Those new values need to be validated. If your before trigger sets a field to an invalid value, this is where the transaction fails, and the entire save rolls back. Step 6 is often misunderstood. The record is saved to the database, but the transaction is not yet committed. Think of it like saving a draft. It's written down, but it can still be discarded. For insert operations, this is when the record gets its ID. That's critical because it means after triggers, which run next, can read the record's ID. Nothing is permanent yet, but the data exists in the transaction. If anything fails between here and step 18, everything from this save gets rolled back. After triggers run at step 7 with the record already in the database. This is where you do operations that need the ID, creating child records, sending notifications based on the saved record, updating related objects. But here's the important constraint. If you want to modify the record that just triggered this after trigger, you can't just assign to trigger.new like you could in a before trigger. You have to perform an explicit update DML statement. That costs one DML operation, and it re-enters the entire 19-step order of execution for that record. Steps 8 through 10 cover assignment rules, auto-response rules, and workflow rules. Steps 8 and 9 only apply to lead and case objects. If you're working on opportunity or account, these don't run. Step 10 is workflow rules. Salesforce evaluates all active workflow rules and collects any field update actions. The field updates aren't applied yet at step 10, they're queued. The application of those updates and the refiring of triggers happens at the next step. Step 11 is the one that surprises most developers. If any workflow rule from step 10 produced a field update, Salesforce applies those updates to the record and fires before triggers and after triggers again, a complete second pass. This second pass does not cause workflow rules to reevaluate, so you won't get an infinite loop of workflow trigger passes. But you will get 2 complete trigger executions in a single save transaction. Your triggers must be written to handle this. Idempotent design. Running twice produces the same result as running once is not optional. Step 15 is where rollup summary fields recalculate, and this is one of the most practically important timing facts in this entire sequence. When your after trigger queries the master record to read a rollup field, say, a count of related child records, or a sum, you will get the value from before the current save. The rollup hasn't recalculated yet because that happens at step 15, and your after trigger ran at step 7. Never make business decisions in a trigger based on rollup field values from the master record. They are stale. Step 18 is the database commit. Everything before this point is part of an open transaction. If anything fails, an unhandled exception in a trigger, a validation error, a governor limit violation, Salesforce rolls back the entire transaction. Nothing is saved. This all-or-nothing behavior is one of Salesforce's strongest data integrity guarantees. It means you don't need to write cleanup logic for partial failures. Either everything commits or nothing does. Step 19 is post-commit logic, and it has a specific meaning. These are operations that only make sense after the data is permanently saved. Sending workflow email alerts happens here. Publishing platform events happens here. And queuing asynchronous apex, queuable jobs, future methods, batch apex, happens here. If your transaction rolls back at step 18, none of these post-commit operations occur. This is why platform events are often used as integration triggers. They only fire when the data that caused them is actually committed. A practical decision framework for before versus after. Use before triggers when you need to modify field values on the record being saved, derive calculated fields, enforce custom business rules that set field values, or clean up input data. Use after triggers when you need the record's ID, when you're creating related records, updating parent or sibling records, calling external systems, or logging activity. The cost difference matters in bulk operations. Before trigger modifications are free. After trigger modifications to the triggering record consume DML operations. The most common mistake developers make is querying rollup summary fields in after triggers and using those values to make decisions. The rollup hasn't recalculated. You're reading data from before the current save. If you need the current aggregate value, calculate it yourself using trigger.new and trigger.old. Iterate over the records in your trigger context, compute the delta, and work with that. Or query the child records directly using a SOQL query scope to the parent's ID. Don't rely on the master records rollup field to reflect the current state of the transaction. Good recursion prevention looks like this: a static set of IDs in a handler class. Before your after trigger performs any DML, you add the current record's ID to that set. When the trigger fires again, because of workflow, because of another update, because of any reentry, you check the set first. If the ID is already there, you skip processing. The key detail is that static variables persist for the lifetime of a transaction, not across transactions. Every new save operation starts with an empty set. The pattern is check, collect unprocessed, add to set, then run DML. The first action step, consolidate to one trigger per object. Salesforce makes no guarantee about execution order when multiple triggers are defined on the same object for the same event. If you have a count trigger and a count audit trigger both listening to before update, either may run first, and that order can change between releases. One trigger, one handler class. The trigger contains zero business logic. It routes to the handler. The handler contains all the logic. This is the only way to get deterministic, predictable execution on a single object. The second action step, build a handler class with a static recursion gate. The trigger file is just routing, 3 to 5 if blocks that call handler methods. The handler class holds the static set, does the processed ID check, runs the business logic, and performs DML. Mark records as processed before running the DML that would cause reentry, not after. Putting the set.add call after the DML means the trigger has already reentered before you marked it as processed. Order matters here too. Add to the set, then update. The third action step, write tests that explicitly verify non-duplication. Don't just test that the trigger produces the right result. Test that it produces that result exactly once. In your test, update a record, and then use count matches or assert equals on a field value to confirm the handler ran once, not twice. Salesforce's test framework runs each test method in its own transaction, so static variables reset between test methods. That means you should also write a test that confirms the static set is empty at the start of a fresh transaction, proving your guard doesn't leak across calls. The full article on Real Syllabus walks through all 19 steps with the complete sequence table, the before versus after decision framework, both the Boolean flag and the set pattern with production-ready code, and an annotated test class that verifies recursion prevention. The order of execution is the foundation that every other Apex pattern sits on. Get it clear once, and trigger bugs stop being mysterious. RealSyllabus.com